Hello guys, welcome to the lecture 1 of our DSA masterclass. In our previous lecture, lecture 0, we already saw some basic uh, loops like for and while and if-else conditionals and how to create functions and everything. So in this lecture, we are going to solve some good level problems, but before that, I would like to explain you about recursion because it is also an important topic which we did not cover in the last lecture. So what is recursion? Recursion is nothing but a function calling itself. So in last lecture we saw what are functions and how we write them and how a function call is performed. So in recursion, a function keeps calling itself until a base condition is met, until like if the condition is satisfied. So let's understand through a problem. If you are given an integer n and you want to find out the sum of starting n natural numbers, how would we do it through recursion? So I will also tell you how would we do it through for loop because it would also be good for revision. But let's start with recursion. So here we have function add, and as we know we are adding integer numbers, so our output would also be an integer. So first we declare the integer data type, like the return type, and then function name, and then the input it would receive. So it would receive an integer n, and those many numbers sum we have to find out. Okay. So first of all, the base of recursion is that we should have a base condition, and when the condition is satisfied, we have to stop the recursion. Otherwise, it will keep on going. Okay. So let's think of a base condition. Here, what we are going to do is, if in this if we'll have our base condition. Okay, I'm leaving it empty for now, and then we'll have our if code. Else, if the base condition is not met, uh, what we are going to do is we are going to call the function itself, add. Okay, so first, wait, I'm going to return the number, return n plus add n minus 1. So here what we did was, firstly, for example, we received the number 5. So we are supposed to do 1 plus 2 plus 3 plus 4 plus 5, which is 15. So imagine we receive the number 5 in here, and then when I call this else, uh, forget the if part for right now. So it goes into else, and I return n plus add n minus 1, which will be, wait a second, which will be 5. So return n gives 5 plus the function calls add function for 4. So n minus 1, when it reaches n minus 1, the function this will call itself again, and here this time instead of 5 it would be 4. So for 4 you can imagine that, okay, it goes again in the else block, and then it returns 4 plus add 3, and then 3 plus add 2, 2 plus add 1, 1 plus add 0, 0 plus add minus 1. Okay, so as you can see, we are going into the negative integers as well, but we do not want to go there. We just need it for the natural numbers, meaning we just need it till 0. So if our recursion n hits 0, we have to stop right there. We do not want to go into negative integers because then the value of our sum will decrease. So in the if condition which we left empty before, what I'm going to write is, if n is equal to 0, return 0. Okay, so now I'll try to tell you, explain this using a tree. Just a minute. So let's imagine that we received the number 5 as an input, right? So then it returns 5 and it calls add 4. Okay, here we had add 5. So this returns 4 and it calls add 3. This returns 3 and calls add 2. This returns 2, calls add 1. This returns 1 and calls add 0. So we know that we set our condition at 0. So when n reaches 0, it does not call another function, rather it just returns 0. So this returns 0. So what happened was, in recursion, we have a stack right here. In recursion, when this function add 5 was called, any function call goes to the stack. So when this function was called, it called add 4, which got added to the stack. Then it called add 3, and then 2, and then 1. So after the function at 0 returns its value, then it gets exited from the stack. It returns some value 0, and then add 1 gets calculated, which was 1 plus add 0, and as add 0 returned its value 0, so now we can calculate 1 plus 0, which is 1, and then its value gets returned. So it returns 1 plus 0 1, and then it also exits. Then here in add 2 we had returned 2 plus add of 1, and we already calculated add of 1, so then 1 plus 2 3 gets returned, and then this, and then this, and then this. So yeah, this is how recursion works. Okay, so now we are going to see what sorting is. In our last lecture, I mentioned what sorting basically is. I'm now going to explain one algorithm of sorting, which is bubble sort. Okay, so imagine we have our array of numbers like 5, 4, minus 2, 10, and 11, and I wish to sort this. So the corrected ascending order would be minus 2, 4, 5, 10, and 11. Now, how are we going to convert this into this? So what bubble sort says is, I'm going to start from this first integer, and I'm going to compare this with the immediate next integer. And if the next integer is smaller than this one, I'm going to swap it. So it would become 4, 5. After this, I'm going to compare 5 with the next integer. And again, if it is smaller, then I would swap it. So this becomes minus 2 and then 5. And then it gets compared with 10, and as 10 is greater, it does not swap, and same with 10 and 11, and it does not swap, and it happens. So after our first iteration, we have this. So and the logic behind this is, if we repeat this n times, n is the n is the length of our array, or the number of elements in our array. So if we repeat this iteration for n times, our whole array would get sorted. That is the basic intuition behind this. So after doing this for the second time, I would have minus 2, 4, 5, 10, and 11. So as we can see, this is already the sorted order, but our computer does not know this, and it would also do this 3 more times, but it would get the same result again and again. But yeah, this is the logic, and the algorithm would be like, for int I is equal to 0, I less than n, I plus plus. Here I would have another loop. As you can see here, we are iterating 2 times. first the outer loop it goes and then the inner loop. So we can implement this using nested for loops. What nested for loops are is a loop inside a loop, and basically it increases our time complexity, because if I run the outer loop 5 times and I run the inner loop 3 times, the total number of times I'm running the loop is 15. So it increases the time complexity by like if it is n, then the time complexity becomes n square, which is exponential. So we don't want that ideally, but in bubble sort we use it. So I would have to make another variable here, and j is equal to 0, j less than n minus 1. I'll explain why it is n minus 1, and j plus plus. And here, if I'll just have to compare the current element and the next element, right? So if suppose array of j is greater than array of j plus 1, swap swap these two elements, okay? uh, and so here I'm using j plus 1 because I want to check the next element. That's why I used n minus 1 here, because if I go to the last element and check for n plus 1, j plus 1, or this element does not exist and it is out of bounds for the array, so it would give an error. So that's why I used n minus 1 there. And so how does swap function actually work? Swap is a very easy logic. Imagine you have two integers, a is equal to 10, b is equal to 20, and you want to swap the values of these integers. So how we do this is, imagine creating a temporary variable. Okay. So what I'm going to do is assigning this value here. So this gets assigned as 10, and then I will uh, assign b's value to a. So a will be 20, b will be 20, and temp will be 10. And I already assigned the value of a to temp. So now I can just change the values of b and temp. So I'll just give b is equal to temp. So a will be 20 and b will be 10. So I'll just write this logic inside of here instead of swap. And then yeah, this is bubble sort. And I want you to explore other options of sorting, like insertion sort or merge sort. And if you have any doubts, please ask. Yep. So now let's see what binary search is. This was one of the algorithm I gave as example last lecture. So what is searching? If I have an array of suppose 100 elements and I want to search a particular number, and keep in mind that this array is in a sorted order, okay? Binary search only works when the array is sorted. So I have an sorted array of 100 elements. Suppose, yeah, it can be any number and does not need to be continuous like 1, 2, 3, 4. It just has to be in a sorted order like 1, 5, 7, and anything. And I want to find a particular element in that array. So this is okay, this is still 100, but imagine it would be like 10 raised to 4 or 10 raised to 3 or something, thousands and yeah, lakhs of elements. So I can't keep on iterating the loop. Like it would just take one iteration and I could easily find it. But worst case, what if the element is in the dead last? It is the last element of our array. So then it would take uh, the loop would run n times basically, which is very long if the array is very long. So what binary search says is, suppose the array is 1, 3, 10, 20, 100, and 110, and I want to find the element 3. So in here, finding through normal iteration using a for loop would be easier because the element is at second place. But yeah, let's try and search with binary search algorithm. So what binary search algorithm says is, place a pointer here. Pointer is nothing but keeping in mind the index of that element. We have another pointer logic which I would explain as and when needed if it comes in some algorithm or question later on. Just keep in mind that pointer is just holding the value of this index, which is currently 0, okay? And I place a pointer right here, which is n minus 1. So right now it's 0, 1, 2, 3, 4, 5. But let's have n minus 1. Let's generalize our algorithm. And I want another pointer k to be in the center of this algorithm, which is okay, this is 0 right now. So 0 plus n minus 1 by 2. This is currently 5, so 5 by 2, which is 2. So okay, so 5 by 2 is 2.5, but we only take the integer value of our floating decimal if it comes, because we'll initiate k as int k, so it automatically typecasts the value into the integer value, and 2.5 would be converted into 2. So 0, 1, 2, and our k is right now here, okay? Let's name this A. A is currently at 0, B is at n minus 1. So what binary search says is, we'll first check the element at k. If the element at k matches our required element, then it is well and good. So we'll compare 10 is equal to 3, which is not the case, it is false. So now we'll check if the element at k is greater or lesser than the element we need. So if the element is greater than the element we need, suppose 10 is greater than 3, so obviously in a sorted order, 3 would be behind 10, okay? So we do not have to check this part of the array right now. So we basically cut our search space into half directly. So, and if like we wanted to search for the element 100, so basically 100 is greater than 10. So we do not have to search for the elements which are lesser than 10 right now. So here now what we'll do is, if our element at k is greater than the element we need, then I'll assign the value of b as k. So b will be here at 2 now, and I'll update the value of k to be again the average of our a and b value. So it would be 0 plus 2 by 2, which is 1. So now I'll have 1 here, k at 1. Now I'll compare this value to the element we need, and it matches. 3 is equal to 3. So, and if it did not match even here, then I will again repeat the same logic, and I'll check if it is greater or lesser than the element we need, and then I'll only search on that part. So suppose there was an element between 3 and 10 and I wanted to search it, so this part I do not need to search right now. So in each iteration, what I'm doing is I'm cutting the space into half, and then if it goes on, so basically I'm doing by 2 by 2 by 2. So these many times I'll have to do it, and the worst case would be log n, because I'm dividing the search space by 2 every time. So the time complexity, worst time complexity, comes out to be log n, which is considered to be a good time complexity. Okay, so let's try and solve a problem right now. This is lead code. Last time we solved on CodeChef. This is just another platform like CodeChef for solving DSA problems. Uh, in this, we are already given a basic template, and we have to write our code in this. This is the input we are receiving. It is in vector form, which is a dynamic array, if you remember, and its name is nums. Okay. So what our problem says is, given an integer array nums, we have to find the sub-array with the largest sum and return its sum. So what exactly is sub-array? So for example, if we have an array 1, 2, 3, 4, and 5. So what sub-array is? It has to be a contiguous form of array. For example, 1 and 2, or 2, 3, 4, 5.
or 3, 4. So, like there is no break in the continuity of the array. I cannot take 1, 2, and then 4. It is called subsequence. Okay. Subsequence is that I am not changing the order in which I am going from start to end, but I can skip some elements. In subarray, I cannot skip any elements. It can be 1, 2, 3, or 2, 3, or 4, 5. This is an example of subarray. So I have to find the maximum sum of the subarray. So here in the example we have if nums is equal to this. So let's try and dry run and find the maximum sum. Okay, minus 2. So it is a negative number and it would not contribute to our maximum sum. So let's just skip it. Next we have 1. If we take 1, okay, then next we add minus 3 to it. So when we add minus 3 to it, it becomes minus 2. Again, it is a negative sum, so it will not contribute to our maximum subarray. So for now, our maximum sum has been 1. Okay. Next, we'll try from 4. Okay, 4. Then we add minus 1 to it, 3. Then we add 2 to it, it becomes 5. And then we add 1 to it, it becomes 6. So for now, our maximum sum has been 6. Now we add minus 5 to it, and it becomes 1. So we do not want to reduce our maximum sum. So let's now try and code it. Okay, there some constraints have been given. The length of the array or the vector would be between 1 to 10 raised to 5, and the elements are in between this range. So keep in mind that we also have some negative elements in here. And okay, let's try and code it. So first of all, we'll have to iterate it. So we'll need some kind of loop. So let's just start with a loop. Int I is equal to 0, I less than, and here we do not have the size exactly. So nums dot size is a function which gives the size of any array or vector. Okay, keep in mind it is a useful function dot size and open and close parenthesis. It will return the size of the array or the vector. So now after writing this loop, mm, I'll need some variables to store. Here the count of this elements of like the count of the length of the maximum subarray is not asked, so I'll not need count. I'll need int. Let's keep in long because the elements can be quite big. Long int max is equal to let's start with 0, and I'll need something for maximum element maximum sum too. So long int max sum is equal to int min. So if you remember, int min is nothing but the smallest. It is the least possible value of integer. So after doing this, so for example, we are on minus 2 right now. I'll just add sum plus is equal to nums of I. What sums plus equal to means is sum is equal to sum plus. This is the short form of writing this. So sum plus is equal to nums of I. But if you remember, we do not want to carry any negative value into the next element because it does not contribute in any way. It will reduce the value. So is if sum is less than 0 means it is a negative value, then I'll just redeclare it to be 0. Now, how are we going to keep tabs of the maximum sum? So I'll write in here if sum is greater than, like for example, if only minus 2 was given in here, like in an vector, there is only one element minus 2. Still, we have to return the value to be minus 2 because it is the maximum sum. It does not matter that it is a negative number, but as it is our only option, then we have to return it. So if sum is greater than our max sum, which is int min, we'll give max sum its value, sum's value. Max sum is equal to sum. Sorry, here I have written max, it is sum. Now I'll just have to return the value of max sum. Let's try and run this. Okay, so all the test cases have been passed. If I submit this, it has been accepted. So I'll just repeat the logic that was in here. I created a variable sum to hold the values that I'm iterating. It is not the maximum sum, it is just the addition of the values that I'm receiving so that I can compare it with our previously fetched values. I need to keep tabs of the previous values too and the current. That's why I've created two variables. And the next variable is maximum, which I'll be returning. This is our result or the answer, you may name it anything. And I've started it with int min because as I said, even if sum is negative like minus 5, I'll have to return it if it is the only option. So we start iterating it, and if I'll add each element to the sum variable, and if the value of sum is greater than max sum, then I'll assign sum's value to max sum. And see, this line has to be before this if. I'll show you what happens if I write this after this if. So here what happens is if I receive a value which is lesser than, okay, this passes the test cases, but I am sure it will fail other test cases. Yeah. So for example, this is our given vector minus 1. It is the only element in here and it is negative. So what happens is I'll add the value of minus 1 to sums. Sum becomes minus 1 and I'm immediately declaring it to be 0 again. So the value does not ever get stored in sum max sum because sum is always greater than max sum and it will just get assigned the value of 0. So this if has to be before this if. So keep in mind the chronology of the code you are writing. It also matters a lot. Yeah.
Now let's solve another question on CodeChef, coronavirus spread. This is a confusing question, so let's try and understand it clearly. It says that there are n people on the street, numbered 1 through n, and for each valid I, the position of the ith person is xi. And it says that the virus will spread from an infected person to a non-infected person whenever the distance between them is at most 2. So okay, and we have to output uh, the minimum and maximum number of people getting infected in that line. So I'll explain to you clearly using the example cases. So in this line, we have two people standing, one at position 3 and one at position 6. So we can see that the distance between them is 3. So if the person standing at 3 is infected, it would not spread to the person standing at 6 because the distance between them is greater than 2. And if 6 is infected in the beginning, it would not spread to 3 because the distance again is greater than 2. So the minimum and maximum persons getting infected is 1. So we have our input here as 1 space 1. The starting number is the minimum number of people, and the second integer is the maximum number. In this one, we have three people standing in a line at positions 1, 3, and 5. So if the position 1 gets infected, it would spread to the person at position number 3 because the distance is at most 2, and then it would eventually spread to 5 also. So the minimum number and maximum number of people getting infected here are 3 and 3. In the next example, we have 1, 2, 5, 6, and 7. If the person standing at position number 1 gets infected, it would spread to the position number 2 because the distance between them is 1. But if a person standing either at position 5 or 6 or 7 gets infected, it would spread to all three of them. So the worst case maximum number people getting infected is 3, and the best case is 2, like the minimum number. So we have to code it beginning with the input of test cases in t, c in t, while t minus minus. Next we have to input n and n, c in n. Now we have to input n space separated integers, and I'll create an array of size n, and using a for loop I'll populate that array. So now the array has been populated. What I'm going to do is, what my idea is that here, if we start from the beginning, here we have to iterate the array, of course. So while iterating, if I reach a breaking point is a point where distance between two people gets more than 2. So if there is a breaking point, I will store that value, the number of persons up until that breaking point, and I will store it in a vector, and then from there I'll add a new element for till the next breaking point, and in the end I'll just print the minimum and the maximum values of that vector. So it does not matter how many breaking points come in between. I'll just have to search for two of the values. So I'll declare a vector here, vector int v. I'll start it by 1. I'll already have a value 1 in there because in any problem statement or in any test case, the minimum and the maximum will always be 1, even if only a single person stands in the queue or no person gets infected through by any other person. So I'll start it with 1, and then I'll start my iterations. So for int I is equal to 0, I less than, I'll keep I n minus 1 here because we are comparing adjacent values. So when I reach the second last element, I can also access the last element, but and I don't want to go out of bounds. So after this, I'll write a code if array of I plus 1 means the next value of it minus array of I, meaning the current value is less than equal to 2, meaning it's in the range of getting infected. What I'm going to do is I'll just v dot back. So this code is for see, in vectors we can access the elements through pointers. What pointers is that? Pointer is the memory location of any element. For example, when I store in an array, each element gets stored at a different memory location. It is contagious in that case. It is not in the case of vector. So when in vector I can directly access them using pointers. So v dot back returns me the value at that pointer. So I'll just have to increment that value. And here I've incremented the value of uh, the last element. I'll explain later why only the last element gets incremented. And else I'll write, if it is not the case, meaning I have reached a breakpoint, then I'll add a new element. What v dot pushback does is it inserts another value into the vector at the last position. So if currently I have, for example, I have 1 2 3 4, and I do v dot pushback 5, then 5 gets inserted at the last element. Now I've successfully done this if and else. If array, yeah. So now I'll just have to find the minimum and maximum values. And maxi is equal to max element v dot n, v dot n, and min is equal to min element v dot begin, comma, v dot end. See out mini, and then I'll have a space maxi. Now let's try and run this. There's an error. Pushback. Okay, there's an underscore here. It is under v underscore back pushback. It's the error max element. Line 34. 113323, so that's correct. Now let's submit and test. Yeah, and it gets successfully executed. So what the previous error was that I did not place a point asterisk symbol here. So what the asterisk symbol does is, basically when a pointer leads to a memory location, I receive the memory location of that element. For example, the memory location of an element at the starting of the array might be 10203, but I want to access the value that is stored in that memory location. So for that I have to dereference that memory location, and this asterisk symbol does exactly that. What this does is, max element, this function returns me the memory location of the maximum element stored in that vector. So it will search from v dot begin. V dot begin also returns the memory location of the first element of the vector, and it will search up till v dot end. So I can even slice the vector and search in between maximum values, but currently I need the maximum value out of the whole vector. So I'll use v dot begin, v dot end. These are two memory locations, and maximum element also returns a memory location of that vector, of the maximum element in that vector. So I will dereference it using this pointer, and then I will get the integer value. So then it can be stored in this int maxi. Before I was trying to store a memory location in an integer data type. That's why it was giving this error. And so hopefully you understood this problem. I would recommend you to also go and solve some problems on your own. And there's going to be this contest this weekend on Saturday. and I'll let you know again later. And also, there's going to be a prize pool of 10,000 rupees. So, yeah, if you want to win that, do participate and give the best of your performance. Thank you.
So, okay, guys, this is the last problem for the lecture, and this Saturday, we'll have a contest on like it will be either on Hacker Rank or on Code Forces. You'll be notified about it on Discord. So kindly join the Discord channel. And also, if you have any doubts, please post on the group chat there, and yeah, interact with us. So in this problem, what we have is Chef belongs to a very rich family which owns many gold mines. Today he brought n gold coins and decided to form a triangle using these coins. So chef will so chef basically forms a triangle. Like the first row of the triangle will have one coin, the second will have two, third will have three, and the nth row will have n coins. So we have to tell what is the maximum number of levels or rows that he may form using a fixed number of coins, and will be given n. So yeah, let's start coding this. So first of all, we have to input t, which is the number of test cases. Let's check if t is less than 100. So while t minus minus. Next, n is a very large integer, so we'll keep long int n, c in n. Now, so I'll keep a variable for counting the number of rows. I'll initiate it with 0, and I'll also keep a variable sub equal to 1. So this sub variable I'm keeping so that it is basically short form of subtract. So in the first row I'll subtract one coin, in the second I'll subtract two. So I'll keep updating this, like I'll keep incrementing this by 1 1 1. So now, okay, so what basically while true does is, while is a loop, you know that in the parentheses of while we write a condition, and the while loop is like the while loop keeps going on until and unless this condition becomes false. So when I write while true, what I'm basically writing is it is an infinite loop. Infinite loop is a loop which never ends. So you get a time limit error because the program does not move forward. It gets stuck in that loop itself. So while true is a infinite loop. So there is a short trick of exiting loops which is used by using break. What break does is basically uh, break basically exits the loop. It does not matter what kind of loop it is, but it exits the loop that it is present in. For example, we are also in this while loop, while t minus minus, but this break will exit the loop in which it is written. So it will only exit this loop. So even though it is an infinite loop, it will break out of it. So what I'll do is while true, if uh, n, which is the number of gold coins chef has, if n minus sub is greater than is equal to 0, meaning if the gold coins he has minus sub, the gold coin he has to use for that particular row, if it is greater than is equal to 0, then we can successfully create a row. So I'll just increment count, and I'll also increment sub, because so we in the next row when we go for the next iteration, I'll have to subtract one more gold coin from it. So I'll just increment sub 2, and I'll update the value of n as n minus is equal to sub. So now we have, for example, for the first row, the sub's value was 1, So if and suppose n is 5, so 5 minus 1, it is still greater than 0, 4. So I'll plant that row right there. For the next row, I've incremented sub, and now n's value is 4, meaning we have one less gold coin, meaning we have 4 gold coins. So for the next, this one, if 4 minus sub, which is now 2, it is still greater than 0. So I'll increment one more count. Count's value is 2, sub's value is 3 now. So and n's value is 4 minus 2, which is 2. So this now becomes false. N minus sub, which is uh, 2 minus 3, it is not greater than equal to 0. So our maximum number of rows which we can make is 2. But now we have to exit the loop. Even though this is false, af- it will skip this if block, but then it will keep uh, reiterating this while loop. It will again go, it will again check, it will again exit, then it will again go. So here in the else, I'll just write break. So if the if condition is false, I'm telling it to break out of the while loop because we no more need to check for anything because it will always be false. So after breaking out of this, I'll just output the count variable. I'll run and check it. 112. Uh, I'm getting one less value right here of count. Wait a minute. So let's check in which test case are we failing. Our output is different for all of these. Let's dry run. First one is 3. So Rn is 3. Count is 0. Sub is 1. While true if n minus sub, which is 3 minus 1, it is still greater than 0. So count is now 1 and sub is also 2 right now and n will be 3 minus 1, which is 2. So now 2 minus 2, it is still greater than 0. So count should be incremented, but our count is not getting incremented. Let's debug this code and check where are we exactly going wrong. So let's go step by step. After inputting the value of t, entering our n's value is 3 now, sub's value is 1, count is 0. While true, n minus sub is greater than 0, count gets updated to 1, sub gets updated to 2, and okay. So yeah, so just now I told you that the chronology of the statements we write is important. This should come at the beginning right here. N is equal to n minus equal to sub. Actually, I was updating the value of sub after I've incremented it. And that's what was giving the error. And yeah, it's been accepted. So this was a logical error. There are different types of errors too. Logical error, syntax error, and everything. Logical error does not give out show any error. You do not know, but yeah, there is some logical error in the code. So you have to debug the entire code, find out where it is going wrong. So this was about today's lecture. It was a short one, but we'll cover more advanced topics in the next one. And so yeah, prepare for the contest which is going to be held on Saturday. And usme, see, we are going to keep scores of everyone who are going to participate. And Those who score the most till the end of this series will get a good prize. Like it's going to be a monetary prize or some gift. We'll tell you later. But yeah, thank you.